All right, I'm going to work through the proof for 45. I'm going to start by changing everything on the left side, like all the tangents and cotangents. I'm going to change all of them to sines and cosines. So that's going to be sine x over cosine x for tangent over 1. I'm going to go ahead and write this as 1 over 1 because I know I'm about to have fractions. Minus cotangent is cosine x over sine x. Plus cotangent is cosine x over sine x. And then on the bottom, I'm going to do 1 over 1 minus sine x over cosine x. So what I want to do now is I want to get a common denominator on each of the bottom of these fractions. So like I'm just going to focus on this next step here and here. And these are going to look pretty similar, but kind of opposite whenever I do common denominators. I want to add these or subtract these two fractions, which means I need a sine x on the bottom of this fraction, which means I need to times the top by sine x as well. So what I have is, I'm going to rewrite the top of the fraction. Okay, I have sine x over sine x minus, oh, sorry, this needs to be a whole fraction. I am subtracting these fractions. Don't worry, it's going to happen. Okay, so sine x minus cosine x is on top, and our common denominator, which is sine x, is on bottom. And then we're going to do a similar thing on this one, except this time I have a cosine on the bottom. So I'm going to times by cosine, times by cosine. So I'm going to have cosine x minus sine x over cosine x. Okay, now I have two fractions over fractions. Like I have two sets of a problem where I have a fraction over a fraction. So what we're going to do is we're going to say, well, sine x over cosine x times the reciprocal of the bottom of this fraction. Okay, if I do that, I'm going to end up with fewer fractions. I'm going to do that with the second one as well, cosine x over sine x. I'm going to flip up the bottom fraction, so that gives me cosine x over cosine x minus sine x. So now I'm going to go ahead and multiply. Sine x times sine x is sine squared x. On the bottom, I'm not going to distribute this through. And then on top on this right one, I have cosine squared x. And now let's look at this. Well, I'll go and write it. I don't want to skip steps and get you lost, if possible. Okay, if I look at this, if I'm trying to get a common denominator here, I actually am really close because I'm really close to being able to use this right here and this right here. These are almost the same thing. So my common denominator for these two fractions needs to have sine x and cosine x from these two things. But what if I really quickly right here said, let me take a -1 out of this fraction and put it in front. And then this would really be a negative cosine x plus sine x. And so this is the same as this fraction over here, or this part of this fraction. So that we really only need to put a negative out here because now we have negative sine x instead of sine x. And then one set of parentheses that is sine x minus cosine x. If you didn't realize to do that while you were working out the problem, you can probably do it without doing that, but it's going to take a whole lot more simplification because you're going to have a much more complicated common denominator. So let's look at what we're missing that we need to multiply by. This fraction has cosine x times sine x minus cosine x. It's missing the negative sine x. So that's negative sine squared x. This fraction is missing cosine x. So that's plus cosine. I'm sorry, that's cubed. Cubed, not squared. On both of these, because we started off with cosine squared, but what is this fraction missing from our common denominator? It's missing negative sine. This one is missing a cosine. So now let's get rid of the negatives we have. Let's say that on the top here I can change both signs to get rid of that negative. And then on the bottom I already have the negative on the outside. And so that makes the negatives go away, which is all I was really trying to do there. And then this is where it's like, we were supposed to know how to do that. Remember that I can factor if I have something cubed minus something else cubed into the difference of two cubes formula. That looks a little bit like this, or a lot like this actually. So I have sine cubed minus cosine cubed. Hey, that's exactly like a cubed minus b cubed. So let's factor the top into sine x minus cosine x. And let's factor the second part, the second parentheses, that's a squared is sine squared plus sine times cosine. And then b squared, which is cosine squared. Well, that's awful, but I'm going to leave it. Sine x cosine x times sine x minus cosine x. Okay, now let's see if anything cancels. Oh, look, sine x minus cosine x, sine x minus cosine x. Hooray, those canceled. And on top now we have sine squared x plus sine x cosine x plus cosine squared x over sine x cosine x. Now, I can feel like I have, oh, okay. Sorry, I thought I'd done something wrong, but we're okay. Whew. Sine squared x plus cosine squared x is 1, right? So even though they're not next to each other, I'm adding all of these together. Sine squared x plus cosine squared x is 1. So that's really 1 plus sine x cosine x over sine x cosine x. And then I can, because let's look at what we were going for. We were going for 1 plus secant x cosecant x. Okay, so that's what this is supposed to equal, is 1 plus secant x cosecant x. And I'm almost there. I can choose to start working with the right side now to get to this, or I can say, well, let's split up this fraction. Let's make it 1 over sine x cosine x plus sine x cosine x over sine x cosine x. That cancels and becomes 1, and this I can switch to cosecant secant, and that's really the same thing as what's on the right side. And there you have it.